Let me offer some review for the LP number 5, just briefly. So the first problem, the average is 27, the variance is 1.21, and then the standard deviation is of course the square root of the variance, therefore it is 1.1, and the upper spec limit is 27 plus 3.25, it's 30.25. The lower spec limit is 27 minus 3.25. It's the situation here. So what is the CPK? Of course, the CPK, you need to calculate both end process capability for the lower part, CPU. So upper part process capability is spec limit minus average divided by 3 multiplied by the standard deviation. Okay, so I believe the answer will not be that different for the lower part, divided by 3 multiply 1.1. Yeah, therefore the CPK is minimum of both. So this gives you the process capability. So it looks like this process is not capable of meeting the specification requirement without generating a lot of defects. Okay, meaning that this is not a capable process. So number 2 is this process centered. So if you conceptually draw the distribution, 27 is here, right? 27 here is here. But because the spec is 27 plus minus 3.25, which is 375, right? At equal distance here, which is both 3.25. Therefore, you can consider this as a centered process. Now, look at the problem number 3. So in number 3, I think the only thing changed here is the average, right? So let's say this is original, and then this is updated. Okay, it's going to be 26. So other than that, I should have copied everything. Anyway, CPK, CP low, CP up. This is a minimum of these two. They'll be calculated. And lower end process cap minus. No, I'm using upper. Sorry. If it's lower, it has to be average minus the lower spec divided by 3 multiply the standard deviation. Okay, and this part is upper spec minus average divided by 3 multiply 1.1. But make sure you wrap it with a parenthesis, otherwise you will get a different result. Okay, so where the upper part is capable, but the lower part is not capable, therefore making this overall process incapable of making the parts. So question number 4. So for the convenience, I'm going to copy everything down here. Okay, and this time let's put it back to 27. The variance has changed to the 40%. Sorry, it's 40%. Dot 4. So spec are intact. So let's double check. Yeah, it looks like almost everything is correct. 64 mu minus 69. Yep, exactly. So this process is now centered, but this is a very capable process. It will make very little defective parts. Okay, last but not least, so this has an average of 34. standard deviation of 7. Upper spec limit is 48. Lower spec limit is 10. Okay, what is the proportion of defects due to the oversize? So conceptually, average is 34, and you have upper spec limit here 48, right? It is asking this part. What are the number of parts? What's the proportion of parts that are larger than 48? So probability of x larger than 48 is equal to 1 minus probability of x less than 48. Okay, we do that because Excel doesn't give us to the right. Norm dist, it's going to be 48. Average is 34. Standard deviation is 7. True. It's less than 2. It's about 2.275%. Okay, this concludes the LP5.